Einstein's postulate of relativity. Einstein had given two postulates, that is, the principle of relativity and the invariant of light speed. So, to continue further, we first need to understand what is frame of reference. Frame of reference is a point in space from where an observer observes an event. To understand this, let's see an example. Here a teacher is teaching, so teacher's frame of reference will be like the student is sitting, and for the student the frame of reference will be like teacher is standing and explaining. Similarly, for you all, this video on your phone is an event, and you all are observer. It is of two types: inertial and non-inertial. If a body is doing non-accelerating motion, that is, either the frame is in rest or in constant motion, it will be an inertial frame. An inertial frame of reference is one in which Newton's first law of motion holds. In such a frame, an object at rest remains at rest, and an object in motion continues to move at constant velocity if no force acts on it. And a frame which is having an accelerating motion is called non-inertial frame. Such kind of frame changes its speed with time. To understand all this, let's jump into the example. Here train 1 is moving with constant speed, it is an inertial frame, while train 2, which is slowing down and changing its speed, so it is in non-inertial frame. When we say that something is moving, what we mean is that its position relative to something else is changing. A passenger moves relative to an airplane. The airplane moves relative to the Earth. The Earth moves relative to the Sun. The Sun moves relative to the galaxy of stars, and so on. In each case, a frame of reference is part of the description of the motion. To say that something is moving always implies a specific frame of reference. Suppose you are in a closed laboratory in which Newton's first law holds. Is the laboratory moving, or is it at rest? You can't say anything, because it will depend on the perspective of the observer. So, the question is meaningless, because all constant velocity motion is relative. There is no universal frame of reference that can be used everywhere, and no such thing as absolute motion. The theory of relativity deals with the consequences of the lack of a universal frame of reference. His first postulate is called principle of relativity, and it states that the laws of physics are the same in every inertial frame of reference. Means no matter which inertial frame you are considering, the laws will remain same. Either you are in a car, plane, or on ground. Example: suppose we threw a ball from particular height from two frames. First ground and second aeroplane. In both the cases the ball will go downwards due to gravity. Another example: take a magnet and a coil. Initially, move the coil relatively to the magnet. Secondly, move the magnet relative to coil. In both the cases EMF will induce. Now comes to the second postulate, also called as the invariant of light speed. It states that the speed of light in vacuum is same in all inertial frames of reference, and is independent of the motion of the source. Now, to understand this, we take an example. Spacecraft A, moving in forward direction with constant speed equals 0.8 c. Spacecraft B moving in opposite direction to spacecraft A with constant speed equals 0.9 c. And an astronaut at rest. All are in inertial frame. A flashlight is turned on from the spacecraft B having a speed equal c. According to Newtonian mechanics, the speed of light observed by spacecraft A will be 2.7 c. Spacecraft B will observe the speed of light equals 0.1 c. And the astronaut will observe the speed of light equals 1.9 c. But the speed of light to all will be same, that is c equals 3 times 10 raised to the power 8 meter per second. Einstein's special theory of relativity gives negligible results on slow speed, but on contrary to this, at high speed, this theory gives you goosebumps. Special theory of relativity predicts such results which cannot be predicted in daily life. Such as, at high speed you will observe that the time slows, contraction of length, energy mass equivalence, the famous equation E equals mc squared, and the twin paradox. Now pause the video and wonder about the astonishing facts about relativity.